basically because mixing has to do with connecting things together. The one thing that is ideal to connect things together is if you have a so-called matrix. And there is this really fantastic little British vintage synthesizer made by the company EMS, the Synthi, the Putney, etc., which has this little matrix, and one of my first synthesizers to play with, so it's very dear to me. And I must say that the Putney, with its little case and the way how you sit in front of it and very comfortably can play the knobs, etc., etc., is still a very good example and inspiration of how you economically can approach an electronic music instrument, because it's super comfortable to play. And so with a matrix you basically can connect everything to everything, because at one side you have all outputs, and at another side you have all inputs. And if you want to connect an output with an input, you just take the cross point and put a plug there or something, or flip a switch or turn a knob or something, and you have the connection. Now, ideally, you would like to have a matrix where all available outputs and all available inputs are present, and you would have knobs. So you can set the level of every connection directly over there, because then you don't need a lot of knobs on the modules. But for a case like this, you would end up with a panel like this, and many knobs, very expensive and also very difficult to sort of find the knob. You can also replace them with VCAs, maybe VCAs that are driven from a microcontroller that is connected to knobs, and where you would have presets and memory so you could store and recall your matrix settings, which is basically what you have these days in all these digital recording systems with the many inputs and outputs, where you sort of have like a matrix. But if you want to sort of do it in a physical format, we are basically limited by the size of the connectors, and well, then it's yeah, you have to find a certain balance of what kind of matrix is still interesting with a certain amount of functions that you have available. So because basically I produce what I call the standard system, which is this size. It is 4 of these panels, because that would give you something that's just portable and a nice balanced set of functions to do interesting things, comparable to many other kind of synthesizers there are. And I found out that the size of this matrix sort of fits well with the system, because in this system you don't really have to use the matrix, because you can make direct connections, but then you can also use the matrix for some extra functions. The way I basically implemented this matrix is that you have the inputs to the left, you have mixing outputs to the top, and you have stereo connectors in the basically as the nodes, as the cross points or nodes in the node field. And these stereo connectors are exactly the same as insert connectors on a mixing desk. If they still have insert connectors these days on these digital desks, I don't know. But there is a slight difference, because normally in a mixing desk where you have one strip with one insert connector, basically the signal comes in, goes through a preamp, then comes to this insert connector, and after that it goes to the equalization and the fader, etc. And then if you put in a stereo jack in the insert connector with at the other side of the cable 2 mono jacks. You can insert these mono jacks into some effect, a compressor, a reverb, or even a foot pedal or whatever, and then have some extra processing on that mixer channel. So it is a very common technique that is basically in here. But I did it a bit different. Actually, in this system we have 2 similar matrices, and because this is already used, I will point to this one. So basically we have 6 inputs. These inputs go into buffers, so-called DC accurate buffers, and these buffers, they have their output signal on the tips of these 4 connectors. Then the rings of the vertical rows are added together in little 6 input mixers to these outputs. So there's basically every vertical column is a 6 input mixer, and these are buffers. So one of the things I can do is I can just take a jack plug like this, and with this jack plug the tip and the ring is internally connected. That means that, for instance, let's say we have a signal here, and if I put in this plug here, you see I have a connection. I can take another oscillator, take that output, put that output into another input, put a jack here, take another one, and that way I can mix. The interesting thing is that if you take like a stereo cable and you put in a stereo cable here, you already hear a little bit of crosstalk. Now if I just use my fingers, because I'm a bit resistive, maybe a bit sweaty or something, you know, you hear that I can actually define the amount of stuff. So
could you use a microphone or something?
Well, you could sort of like this light, dependent resistors. You can use a volume foot pedal. You can basically use anything which is resistive. Yeah. So I added a couple of extra functions here that specifically work with these cross points on this matrix, and I call them node processors, because the cross points are called nodes, the nodes in the matrix, and you can enter a certain processing on the node, similar to how you would use a compressor in a mixing desk strip using the insert connector on the mixing desk. So for instance, there are 2 simple pots here. So what I can do is I can connect this to this pot and now set the level of this pot. And if we have another stereo cable, small stereo cable, did somebody take the short?
That one in front of you, that's
the other one.
Oh, yeah, here I have another one. There's supposed to be 6 of these that come with the system if you buy it. So I have another pot. I can use that in this one, and now I can basically mix those 2 together any way I want. Okay. Now, let's say that you want to do mixing under voltage control. There are 4 VCAs here, and instead of using these pots, you can also use a VCA. So I just set this VCA 1 into a sort of like the standard mode. I connect it here, and now now I can basically open it here, but I can also take an LFO signal and have it under voltage control. There's also some other very important use of this matrix, and that is that if you enter a signal here and you want, let's say I have this, here I have an LFO signal. It has only one output connector. So if I connect it to one input, I cannot use that signal anymore for anything else. But if I connect it into the input of a matrix, then this signal that comes in here is available on the tips of all these 4 connectors. So basically now I can put 4 cables in here and route the signal to 4 different destinations. And one of the good things is that for this you would use a mono cable, because if you use a mono cable, then the mixing input on the ring would actually be short-circuited to ground, and you would not have this signal interfere with the mix. Because, let's see, yeah, we have this signal here. Now if I would put in a stereo cable, and let's see if we can. That's not really. Oh yeah. You can hear how this LFO, that's now almost in the audio range, sort of leaks through. And you would have a bit of crosstalk. But if you use the mono cable, then of course you don't have that, because the mixing input there is grounded. So I can safely now use this signal to modulate the mix of this one oscillator. And use a second VCO for the other oscillator, which, let's see, I basically invert the modulation signal. And I can do very quick effects like this. Okay. A matrix is actually quite a versatile thing, because at the same time I can use it for mixing. I can use it as a so-called multiple, where you split one signal into several branches. And I can actually also feed back an output into another input of the mixer, matrix, and that way actually create very complex feedback paths and stuff like that. So it's something that is, well, you don't find it this way on other synthesizers, so you would really have to play with it for a while and test it out. And from all the systems that I sold in general, people were sort of like, matrix, what, very complex, and then I tell them, there's a little description of the things that you can do, and then I tell them, well, just play with it with an evening, and then 2 months later I get this reaction, I don't know how I could ever live without this matrix.